And before getting into the details of setting a Hive and Impala, first you need to understand where those tools fit. There is a reason why I have clubbed both of them into one presentation. You will understand by the end of the presentation. But out of those tools, Hive is a MapReduce basis solution, and Impala is a non-MapReduce basis solution. And now we'll get into the presentation, and then by the end of the presentation, you will understand why I have clubbed those two. Let me see. Okay. So as part of this, we will see overview. We will talk about Hive architecture. There is something called Hive Metastore. We'll set up Hive using Cloudera Manager. We will review the parameter files. We will review the log files. We will see what needs to be done with Hive user defined functions. And we will see a Hive demo. And then we will talk about Impala in the similar manner. And in the end, we will talk about Impala versus Hive. Okay, so the reason why they came up with these tools like Hive and Impala is that writing MapReduce jobs can be tedious. So even to write a simple query, even if you want to write a reusable count MapReduce function, which can run on any data set, it can be quite tedious, and it can run into few hundred lines of code, and it can be buggy. So it's not only tedious, it can be buggy as well. And most of the people might not be even comfortable in writing Java code or any typical programming language. Means a developer might be able to, but a business user who just want to validate the data might not be able to write MapReduce program. Similarly, a data analyst or a business analyst cannot write complex programs using programming language like Java. And for those kind of people, they have come up with alternatives like Hive and Impala. And first, let me show you a row count program, which only deal with certain kind of data set, and that could be actually few tens of lines on this one. Yeah, so this is the row count program. And this do not have mappers or reducers, but still it is almost 20 lines or 25 lines of code. And then there are mappers as well for this program. And this is again another 10 lines of code. And then there is a reducer as well for this. And there is another 10 lines of code, at least 50 lines of code to write a simple count. And this code will not work for all kinds of data sets. If you want to write a common row count program, it can run into 200 or 300 lines of code if you want to use it for all kinds of file systems, all types of files as well as all types of data sets. So for that reason, MapReduce might not be practical for most of the simple use cases. And vast area of IT stakeholders have basic proficiency in SQL. So I'm not talking about when I say IT stakeholders, they could be programmers, they could be testers, they could be analysts, data analysts, business analysts, and they could be management. So all these IT stakeholders have proficiency in SQL. So for those kind of people, they came up with solutions like Hive and Impala. First, we will see what is Hive. Hive and Impala both can by we will try to use SQL type of syntax, but Hive we can write queries which will generate MapReduce code to process the data. So when you run a Hive query like select count of 1 from a table, it will generate code like this, a MapReduce code which will be written in Java like this, and it will be compiled and it will be submitted as a MapReduce job. Okay, it will accelerate application development in Hadoop ecosystem. Definitely, you can not only write a simple query like select count of 1, you can write Hive queries to join the data sets, to do group by, you can do aggregations, you can do a lot more stuff than using Hive queries. So it will definitely accelerate application development in Hadoop ecosystem. It has 3 main components. One is DDL or physical modeling. So as Hive uses SQL, first of all, you need to define structure to your data in HDFS. And that's where DDL comes into picture, where you will create the logical structure for the data in HDFS. And then you can copy data using commands like load or insert, and you can query data using HiveQL. Okay. We will see a little bit overview about these things as part of the demo. And this is the Hive architecture. It uses HDFS as the foundation to store the data. And then it uses job tracker or resource manager, whatever framework you are using to process the data. Yes. And then when you actually run the query, there is a Hive, so the top blue rectangle is Hive, and there is a driver or engine which actually compiles, which actually creates the code, compiles the code. It can even optimize the MapReduce that is developed to execute a query, and then it will execute that as a MapReduce application. So this driver or engine will take care of compiling queries that are written in SQL format into MapReduce code, and it will take care of even execution of the code. And as I mentioned to you earlier, you need to define a logical structure on top of the existing data. So this metastore will be used. This metastore will be used to store the logical structures. You will see the. Let me show you a simple Hive query simple create table command for Hive, and then you will understand the relevance of the metastore. Okay. So let me open a new shell. So the query will, and the create table command will look like this. And actually based upon the table name, it will create a HDFS directory. And then you are defining the structure on top of the data that is in HDFS. And here you are defining the delimiter. So in our case, the delimiter is pipe. And we are assuming that the data will have 3 columns. So that's where, so this is kind of metadata. And that defines the structure of the data in a HDFS. And this needs to be stored somewhere so that you can leverage this information to run the queries like this. Okay. So without the knowledge of the metadata, you will not be able to write. Means the Hive cannot be able to execute the queries. So for that, it requires a metastore, and that's what this represents. So it actually stores that metadata of column names and column types here, but the actual data will be in DFS. Actual data will never be in the Hive layer. It will be in DFS itself. Hive is completely logical. It can have structures on top of the data which is in HDFS, but Hive itself will not store any data in its layer. Okay, and above this metastore and driver, we have few rectangles which indicate multiple ways to interact with Hive. One of them is the CLI, which stands for command line interface. So we can run Hive queries from command line. I'm not sure about HWI means Hive web interface. So you can also use the Hive web interface to run the queries. And then thrift server is for non-Java based languages. If you want to write Hive queries, then you have to go to the thrift server which exposes REST APIs. So you can use REST APIs through thrift server to communicate between non-Java based programming languages to interact with HDFS using Hive queries. And JDBC or ODBC are just connectivity. So if you are a Java developer, you know what it is. And then using these services, there are again a few additional tools to interact with Hive. We will see Hue later, but others I am also not aware. So as long as you understand Hue and Hive command line interface, that is more than enough. And also as an administrator, you should configure thrift server so that anyone can interact with Hive using any programming language. So now out of all these green rectangles on top, only Hue, command line interface, and thrift server are important for administrators. Okay, so this is more about Hive architecture. All the data physically stored in HDFS, as I have explained earlier. Data is processed during MapReduce jobs. Metastore stores structures of tables. Hive query engine generates Java code at runtime, compiles and builds jar at runtime. So this Java code will be based upon the Hive query you have submitted. So for a given query, it will generate the Java code at runtime. It will compile and build jar at runtime, and it will submit as one or more MapReduce jobs depending upon the complexity of the query. Okay, now we will set up Hive using Cloudera Manager. So now I am going to the Cloudera Manager. Let's see. I think because we played with the cluster, some of the data is lost, so that's why it is complaining. Yeah, okay, 6 missing blocks. I will troubleshoot this issue later. So now let us add a service, and here we are trying to create Hive. Click continue. Okay, Hive requires HDFS and Garn. Zookeeper is required if you want to interact with Hive as part of your programs. So it automatically selected everything. So you can click on continue. And it automatically picked all the nodes as gateways. And then it is asking for Hive metastore. I would like to configure Hive on the same on the gateway node itself, and then Hive server 2 is a thrift server, I think, and then you don't need to configure web hcat server, and unless you are running Hive server 2, developers will not be able to connect to Hive. So it is very important that you configure Hive server 2 as well. Okay, hit continue. And as you see in the picture, metastore requires the database. Okay, and in this case, we can choose by default it self Postgres, but we want to create our metastore on a custom database which is running on MySQL. So MySQL port number is 3306. So before going ahead and clicking on test connection, we will try to log into our MySQL database and see whether there is a database with name Hive. Okay. So I am logging in as root -p Hadoop 20, and you can run four databases, and there is no database with the name Hive. Okay, so you can actually use existing databases like RMAN, MySQL, and information schema. We should not use their system databases. You can use existing database like RMAN, but it is not a good idea. RMAN is mainly for our Cloudera manager, and if you try to use RMAN, it might work. But if there is a conflict between table names between the tables that are being used by Cloudera managers and Hive, then it can cause issues. So it is even though it is possible to use existing databases, you need to create a new database for each and every component. So in this case, we will create a new database for Hive. So let's create database Hive and create user Hive identified by Hadoop 20. Okay, and then grant all. First, we have created Hive database, and we are now then we have created a user. If you are using Oracle, then you have to just create a user. You will not create a database like this. And the way Oracle works is different to MySQL, so you need to first understand your database architecture before creating the repositories for the metastores. Okay, in case of Oracle, there will be only one database, but there will be multiple schemas or users, and they will own the tables. Whereas in MySQL or Postgres, you can create as many databases as you want for an installation. So don't follow the same steps if you are using a different database. If you are using Oracle, you need to understand how you have to set up in Oracle. You can go through the documentation of Cloudera, and it will give you instructions of how you should proceed with Oracle. But in this case, we are using MySQL, and for MySQL, you have to create a database, then you have to create a user, then you have to grant all on the database Hive.star. Star means all the tables. All means all the privileges to create a table, to insert, update, delete, drop, everything to Hive. Now the database is created, user is created, and we have granted all the permissions. So the password is Hadoop 20. Click on test connection. So it is successful. Click on continue. Save password. Click on continue. Now, if you see, now I have switched to Hive database. It is a new database, so there were no tables when we actually created the database. But after the step is done, creating Hive Metastore database tables, if you run store tables in the Hive database, all these tables are created. Okay, so first it created the tables, then it is creating a Hive user directory. So Hive user directory means it is in HDFS. So if you look at Hadoop SS -ls /user, before setting up the Hive, there is no a directory called Hive under user. But as part of the installation, now if you see the time, it is Eastern time. Just now it has created the, actually you can run date, so it just created 1 minute back. So this step, which says creating Hive user directory, has created this directory. And then, if you see what is there in Hive, there is a directory called warehouse. So the third step is creating Hive warehouse directory. So when this step is executed, it has created this directory. Okay, and then now it is starting the Hive service. So as part of starting the Hive service, we have a Hive server, we have Hive Metastore service. So all those services are being started as part of starting Hive service, and then it has deployed the client configuration on all the nodes. So as part of the start service, it has started Metastore server and Hive server too. Okay. So now Hive setup is done successfully. Everything is clean. Okay. We will see we will see more details about the relevance of creating this directory and all those things when we actually look into the demo. Okay. And now we will review the hive.xml file. So as I have mentioned to you earlier, all the parameters files will be under var run, Cloudera, SCM agent, and process. Okay, I have to do sudo su root. So only admins will have access to this directory, and these directories which are under var run Cloudera SCM agent process actually represent the latest configuration files. And whenever you make changes and redeploy, it will create a new directory. The reason why it is creating these many directories and why it will create a new directory whenever you make changes is to keep track of all the changes, and you should be able to roll back your configuration to the previous copies if you run into any issues because of the changing of parameters when you actually manage your cluster using Cloudera. And this is all Cloudera implementation. Don't expect the behavior to be the same if you are using different distributions of Hadoop. Cloudera is more organized than any other distribution I have encountered so far. So the way these parameter files are managed will be dependent on the vendor who provide the management utilities like Cloudera managers. Okay, so you have to look into the latest directories. So in this case, there are two directories, one for Hive Server 2 and Hive Metastore, and also the deploy client configuration will have the latest parameter files. Okay, let's pick the 205 and LSLTR. You have Hive conf. So you have for Hive, we are primarily interested in hive.xml file. So this will have all the parameters that are related to Hive. And as it uses HDFS and MapReduce to process the data, it will also have copies of core site and YAML.xml files. Core site, HDFS site, YAML site, and MapRed site, which are related to HDFS and MapReduce respectively. In this case, we are interested in Hive. And here, so there are few important parameters like Hive Metastore URIs, which will actually provide you the URL and port number for the Metastore service. And then this is the one which I'm talking about. So when we actually set up the Hive, one of the steps is it tries to create a warehouse directory, and it is controlled by this parameter. So wherever this parameter is, whatever value this parameter is defined to, Hive will try to create this database, and this will be the default database in Hive. We will see that again later, but this is very important. Means if you create tables and if you are not seeing the tables under user Hive warehouse, you have to understand the value of this parameter, and you have to use this base, and then you have to search for your table in this location. We will see that as part of the demo, but this is a very important parameter in Hive configuration. And then there are many other parameters. the next important one is zookeeper quorum and port number. So if you want to, if developers want to connect to Hive, you have to pass on this zookeeper quorum and port information, and they have to use it as part of their Java programs. Okay. So those are the main parameters which I can think of in Hive. So I have provided a slide with all the important parameters. So there is one parameter called map_reduce_stars, which is defined as -1. And if you remember, when you run map_reduce jobs using the command line Hadoop jar command, by default it will use one reducer for any job. Whereas in Hive, it is defined as -1, and Hive engine will determine number of reducers based upon the size of the data that it has to process. Whereas the typical map_reduce program, they will only use one by default, but Hive you have a logic to compute the number of reducers when it actually run the program. Okay. And then apart from this XML file, you can override certain parameters. So, okay. So now the Hive is configured using Cloudera Manager, and you can run your queries by getting into the Hive command line interface. To get into the Hive command line interface, you can use command called Hive, and it will launch the Hive command line interface, and you can run queries from here. Okay, I will show you as part of the demo how to run the queries. But apart from XML files, which we have seen, if you want to override certain parameters for all the queries that are being run by HD user, then you have to create a file called a hidden file called .hiverc. Okay, and you can define certain parameters here, and they will the values set in .hiverc will override the parameter values that are set in core site or HDFS site or YARN site or MapRead site or Hive site. Any of these 5 files. If you want to override any parameter that is part of any of these 5 files, you can override using the .hiverc, and the overridden values will take precedence whenever you run Hive queries. Okay, I will show you again the relevance of .hiverc and how you set parameters when we do the demo. Okay. And the Hive log files, so when you run the Hive queries, so let's do one thing. You launch Hive query, Hive command line interface. And you can run command like show databases. And by default, it will show only one database, which is called default. And all the tables that are created under default will go under user Hive warehouse directory. I will show you again later. But for now, I want to show you where the log files will be. The log files will be under temp by default. Okay. So you can go to temp, and you can do lsltr. And whatever user you use to run the Hive commands. So in this case, we launch Hive command line interface using user HD user. So under temp, there will be it will create a new directory with that user if it does not exist. So in this case, it has created HD user, and you can run ls-ltr, and you will see the Hive log file over here. Okay, and then it will log all the relevant information whenever you run the queries. Again, we will come back to this as part of the demo. But the location is /tmp/os user, which is HD user. So if you run pwd command, this is the location where you see the Hive logs. Similarly, if you, instead of using SD user, if you log into root and if you run Hive from here, so you get into the Hive, and now you can do exit, and then you can see temp, and the root user is, the directory for root is created, and you can see a Hive log file here. So whatever user you use, it will try to put the logs under /tmp/that username. Okay, that is about log file. And then user-defined functions. By default, when you run Hive, there are a bunch of functions which are pre-created as part of the Hive installation. And you can, as an admin, you need not have much insights into all these functions. But if you are from a developer background and if you actually dealt with SQL queries, and if you have used Oracle functions or SQL Server functions or any other database functions, they are similar but not same. But and the concept is same. You can have user-defined functions, and these are off-the-box user-defined functions. You can get the list of user-defined functions using command called show function. And now, if you want to write a new, if the developer want to write a new function, administrators will not write new user-defined function for Hive. If developers want to write a user-defined function, they have to write, and they have to understand Hive APIs, and they have to write them in Java. And once they write it in Java, they will provide you a jar file, and you have to add the jar file, and also they have to give you command to create a temporary function, which you need to run for them to run those commands as part of their queries. And to make them persistent, you have to update the Hive.rc file for that user, which developers will use to run the Hive queries, and that user-defined function will be persistent across multiple sessions. So these are the high-level steps which an administrator needs to be aware of to add new user-defined functions as part of supporting Hive. They just have to add the jar files which are provided by the developer or third-party vendors, and then they have to create a temporary function, and those two commands to add the jar file and creating the temporary function have to be updated in .hive.rc file. Okay, now we will see the Hive demo. So before getting into Hive demo, so far we have seen Hive command to launch the Hive command line interface. There is some question, let me. We'll take a break after this demo. Okay, so first we will see how you can interact with Hive command line. There are three ways to interact with Hive command line. So far we have seen Hive command. There are two other ways, Hive-E and Hive-S. And the purpose of Hive is to launch the command line interface. You can run multiple Hive queries when you are in the command line interface, and you can run exit command to come out of the Hive command line interface. In some cases, you might want to just execute a query like show functions, and you want to come out of it immediately. Instead of launching the command line interface and stay within the command line interface, you just want to execute a command and you want to come out of the, you want to come back to the OS terminal OS shell which we are using. So now we are in the OS shell. If we run Hive command, we will get into Hive shell. We don't want to get into Hive shell, but still, if we want to run Hive queries, you can use Hive-C command. And if you hit enter, it will execute the Hive command, and it will come out to the terminal again instead of getting into Hive. And then other way is to run Hive-F. So if you want to create a script of multiple Hive queries, and if you want to schedule in cron or some other, or if you want to integrate with the shell script, what you can do is you can create vi test Hive .hql. Okay, you can say show function. Okay, now LSL here. You can actually do Hive-F test Hive.hql. So it ran the script and it came out. So if you want to group multiple Hive commands and if you want to run it as a script, you can do it using Hive-F. And this you can actually schedule using your enterprise scheduler tools, or you can even integrate with any shell scripts, etc. So there are 3 ways to interact with Hive. And then we will talk about set first, and then we will talk about Hive-Conf. Okay. So when it comes to parameters, means any software product is driven by parameters. And if you want to see the parameter details, you can issue a command called set in Hive. So if you do set, it will give all the commands. And when you actually run the set command, it will actually it will get all these parameters from different sources. It gets from system, it gets from env, which is the environment variables. It gets from HDFS site, core site, mapped site, Hive site, all the XML files that are relevant for Hive, and it will display all the parameters here. Okay, and if you want to see a particular parameter like mapped.job.reducers, no, not this one. Let me see the parameter name. mapped.reduce.tasks. If you want to see a particular parameter, you have to give that here. Oh, I'm sorry, it's set. So it is -1. If you want to see all the parameters that starts with mapped, you can do mapped.star. I forgot the command. You can actually use the patterns also. Yeah, I think I know. Set mapped dot. No, I don't remember the actual command, but you can actually look at parameters like this as well. All the parameters that starts with mapped, you can get them something like this. So in this case, we are to see the value of a given parameter, we can run this command. If you want to override the parameter, still you have to use set, and you can say tasks equal to 1. Now, if you use -1 for mapped.reduce.tasks, Hive will determine how many reducers should use for a given query. By setting it using set command, irrespective of the size of the files, for all the queries run as part of this session, it will only use one reducer. We will see that again later. Now again we will see the value. Now it is 1. If you do exit and if you go back again, you can use up arrow to see to get the history of your Hive commands. So now again, if you see, it is -1. Okay. So now what we will do is we will use the same command. Under home directory, we will create a Hive file. And now we will set it to 1. Okay. Now if you do Hive, and now if you look at test metric dot task, it is 1 because we are using .hive.rc, so it will override the parameter which you have given under .hive.rc using the set command over the typical XML files. So this will take the precedence. So if you want to override for all the commands that are run by user HD user, you have to create .hive.rc for that HD user under the home directory. So tilde represents home directory, and it will override for all the sessions which are used to run your Hive queries. Now, if you get out of Hive and sudo to root, yeah. So when you actually run the Hive queries, and if you go to your resource manager, and if you look at the configuration for your Hive query, it will that are run by HD user, it will show as 1. If it is -1, then it will change at runtime. So now as a root, I am running the Hive query. Sorry, Hive command prompt. And now let us see what is mapped.reduce task. It is -1. Because the Hive.rc is created only for HD user, this parameter is only will only override for the Hive sessions that are triggered by the user HD user. If you want to again override certain parameters for root, again you have to create a .hive.rc file for root, and you have to override all the parameters which you want to override in that .hive.rc file. It is very important to understand .hive.rc because you will end up overriding a lot of parameters for performance tuning when you actually support the actual applications. Okay. And also, if you want to override a particular parameter when you run the command, so let's say you want to do Hive -e, or instead of using again, let's go to .hive.rc and delete it. I deleted it. So now, whenever I launch the command prompt, for that session only, if I want to override a parameter, then what you can do is you can use Hive -hiveconf, and then you can set mapped.reduce.tasks equal to 1. Okay. And now if you run that command, it is 1. It's not because we have changed in .hive.rc, from .hive.rc I have deleted. It is because of this hiveconf command. So you can override for that session using -hiveconf. Even if you have the same parameter in .hive.rc, let me demonstrate this. va.hive.rc equal to 1. Now if you run Hive, it is -1 because wait, it should not be -1, it should be 1. I think I'm not in the home directory, pwd. Yeah, that is the reason why. So you have to create only in the home directory. Now I have created in the home directory. I'm in the home directory. Now if I run Hive, and if I check the value, it is 1. Okay, because it is from .hive. The actual parameter in hive.xml for this is -1, but it is showing as 1 because we are overriding at user level. So all the sessions that are triggered by the user HD user will inherit the value from .hive file, and it will override the settings from the original XML files. Now, if I want to override the same value for a particular session, I can use -hive-hiveconf and give the parameter. And now if I try to see why it is giving 1, it should have 2. Probably syntax might be incorrect. Let me see. No, it is only giving 1. Okay, that is weird. I probably my understanding was incorrect. I think it will not override the settings from .hive. So if you want to change your runtime, then you can actually run this command. Means it will only change as long as you reset that value in a given session. So this is the set command and hiveconf command. Let's do one last thing. vi.hive and delete it. And now let me launch it. Yeah. So I think hiveconf will not override from .hive. So that's why we are not seeing that value before when we have 1 in .hive. Okay. So let's take a break here. It is taking a lot more time than I expect. So I will pause the recording because after the break, we will resume with the rest of the stuff. It will take some more time, around 15 to 20 minutes before we complete the entire demo for Hive, and then we will talk about Impala. See you in 10 minutes. Now it is 9:39. We'll meet again at 9:50. Okay, so we'll resume the demo. So now we will start creating the tables. Sorry, first we will start creating. First we'll create the databases, then tables, and then we will see how to copy the data into Hive tables, and then we will see sample queries. And I have already shown you the role of .hive, and we will also see troubleshooting the map reduce jobs for Hive queries. Okay. So the script that is used to show the demos for both Hive and Impala is under scripts directory, and it has the entire script which is used for this demo. Okay, let me first open the scripts. So first we can create the database like this. The command create database if not exists cards. So what it will do is, if the first let us see what all databases are there. By running show databases command, there is only default database, and when you actually run this command, if the database does not exist, it will create. If the database exists, then it will not do anything, but it will not give the error. If you do not have if not exist, and if the database already exists, it will cause error. And as I have shown earlier, we have multiple ways to run these commands. One of them is Hive-F. So when you use Hive-F, you typically group multiple Hive commands into a script, and you will try to run the script. And as part of the script, even if one command has an issue, it will just abruptly stop the rest of the script, and it will come out of the script. So typically, when you use Hive to store the database for your HDFS data, as part of the processing data integration framework, which is developed using Hive, you will end up creating databases or tables at runtime. And if the tables already exist or database already exists, we don't want the script to abruptly stop. That's where this if not exist comes into picture. So now let us run this command. Control-C. Now it has ran successfully, and if you see show databases, now you can see the database. Now if you run it again, it says okay, but internally it will not do anything. But if you don't have if not exists, it will throw an error, and it says database cards already exist. So we don't want these things to happen if you want to run this as a script. In those scenarios, you can use if not exist for both table as well as databases, so that things will not abruptly stop. Now let us see what happened in HDFS for this after we run this command. You can issue HDFS commands using DFS. DFS is nothing but an alias for Hadoop FS in Hive, and you can give -ls. So DFS itself is Hadoop FS. So you can directly go with the subcommands under Hadoop FS to see the information in HDFS. And user Hive warehouse is the warehouse directory. It is the base for your Hive database in HDFS. And if you see, earlier when we actually before creating the database, there is nothing in there. It's just empty. But now we created the database at around 12 minutes back, and it has created a new directory with extension .db. So all the databases that are created using create database command will internally create a database under under this one. And if you could not see under this location, that means your hivesite.xml and the parameter which drives this warehouse directory might be pointing to a different location. So you have to go to that hivesite.xml and see the value of it, and you have to query that location to get the results. Okay, and now to switch to the database, you have to use command. Hive follows MySQL or Postgres for most of the commands. So that's where you can create any number of databases using Hive, and store databases to show the databases, which is also same in MySQL. To switch the database, you use Karte. Okay. Now let's create a Hive table. Okay. So before creating the Hive table, let's see what is there under the cards.db. It is empty. That's why it is not returning anything. The reason it is empty is we just created the database and we haven't done anything. Now let's create the Hive table. So as part of the create table command, create table looks like typical create table commands in traditional RDBMSs. The first major difference is the data types. In typical RDBMS, you see char, varchar, glob, and many other data types. And also you see the precision or length for your fields, whereas in Hive, there is nothing like that. It only, for all alphanumeric types, you only use string. And also there is no date data type in Hive. Even date will be represented as string. But there are numeric types as int, float, double, etc. So you need to understand all the data types before you start creating the tables and start your physical modeling. So I'm not getting into details because that is out of the scope of admin course. In this demo, we will just see how we can validate whether our database is working as expected or not. It is very important to validate after setup or upgrade or migration of all the components before turning around your environment to the developers or production support for day-to-day activity. Okay, so we are going through that phase of validating our setup. So let's create the table. And after the data type, as I mentioned previously, we have to define the delimiter using which we will be storing the data. And then stored as text file will determine how the data will be stored. Okay. So first we have created the database with name cards. So for any database you create, it will create an directory. So this cards.db is nothing but a directory under user Hive warehouse. Okay, and .db will tell that this directory is related to the database. So we have created a database using if not a create database if not exist cards, and then we have validated what have happened internally in the Hive in HDFS. So this is HDFS. And now, and also we have validated if we have anything under cards.db, there is nothing because we haven't created any table. Now we are creating the table. Okay, now table is created, and now run the same command to see what is going on under cards.db. So it has created the directory called large_dex, and it is same as your table name. So for any table you have created in Hive, which is a logical structure in HDFS, it will create a directory in HDFS. Okay, and all this information will be stored in metastore, which is in MySQL, which we have configured while setting up the Hive. Okay, now if you look at this directory, there is nothing in there because we just created a logical structure. We haven't copied any data. It is empty. So you can copy the data, and then we will see what will happen. Okay, and you might be familiar with the describe command. Describe is supported by most of the traditional RDBMSs to see the properties of the table. In this case, large_dex is the table name, so you can use describe command and give the table name, and it will give you all the column names and the data types. If you want to see more information, there is describe extended, and you can give large_dex with this table name, and it will give all the information related to the table. But the output is a little bit clumsy, so there is another command called describe formatted, which is similar to describe extended. Describe extended will give you all the information. So if you want to see all the information, you can use describe extended. But describe formatted is a alternative which will give you in readable format, and that is more than enough for DBS and developers for most of the scenarios. If you want to understand the properties of your table, I highly recommend to use describe formatted command because it is much more readable. You can give the table name, and now you can see all the details of your table. So first it has given the column name, and then it has given the database in which the table is created. One is HD user, and this is the location under which the directory is created in HDFS. It is a managed table. There are two kinds of tables in Hive. One is managed and one is external. I will not be explaining those things here. But here managed table tells that this is a managed table. And then the third library, it uses Hive serialization deserialization framework. Again, it is not relevant for administrators, so don't worry about third library. And input format and output format will determine how this data is actually supposed to be read. And depending upon the stored as, this input format and output format will be determined. And if you say stored as sequence file, the input format and output format will change. The reason why administrators need to understand is Hive does not enforce anything when you copy the data, especially using load command. We will see the load command in a moment. When you use the load command and when you actually store the data in Hive, it does not do any validation, it will just dump it. And then when you actually try to run a query against it, if the format that is determined while creating the table and the data that is stored does not match, then you will start seeing the issues. So if there are such complaints by developers or business users, you have to understand what is the input format of the table and what is the format of the data that is stored under the directory. If they don't match, then there is some issue with the developers, and developers have to fix that. To troubleshoot the issues, this will come handy to administrators. So they just need to understand that the input format which is specified here should match with the files that are being stored in HDFS using load command. Otherwise, you will see inconsistencies with the results. Okay, so let's copy this file called largedeck.txt using load command. What load command does is, it will not run any mapages behind the scenes. It will just run command like Hadoop SS -put. So it will try to copy this file into this table. Okay, let's run this command and then we will validate the results, and then we will understand what will happen behind the scenes. So the location is incorrect. So let us see the location. Okay. Okay. mkdir -p data cards Hadoop SS -ls. Okay, Hadoop SS -get. -get is, as I don't have data in this gateway node, I'm copying the data which is in HDFS to my local file system. So -get is the command to copy from HDFS to local file system, and the location is hduser/largedeck.txt, and I want to store into data cards. Okay. So now it will copy that file from HDFS to that location. It will take a while. Okay, so data is copied. You can validate it by running data cards, and you can see the file largedeck.txt. Now go to Hive. And you need to make sure that you are in a right database. So you have to use command. By default, it will log into default database. So if you want to switch, you have to use command, and then we can run load command. Now it is copying data from this OS location into this table. This table is nothing but a logical structure on HDFS, which is user Hive warehouse Karte.db large deck. The location is created when we actually create the table. So now the table is copied and the size is 2 GB. And now let us see what is going on under the location where table is created. Okay, now you can see this large deck.txt file is created in that location. That is not the correct statement. It will not get anything from all other nodes to Hive table. Hive table is nothing but a logical structure, and that logical structure will be stored in Hive metastore, and all the data will be in HDFS only. It will not get anything to Hive table. Hive table represents the location in HDFS. Okay. So in this case, if you see again display formatted command, if you see display formatted, so this table represents this directory in HDFS. Whatever data copied to this location will be can be accessed using the table as part of your queries. Now you can run the queries like select star from large deck, limit 100. Now you can see the data. Okay, as long as the data is there and the input format of the input format defined at the table creation and the data that is actually stored in the location matches, and also the delimiter is same between the data in HDFS and the table definition, you will see the results without any issues. Okay. Okay, we have not gone into query yet. We are talking about load and insert, then we'll talk about queries. Okay, now we load the data into HDFS. Now we will see the insert. So there are two ways to copy the data into Hive. One is load, which we have seen just now. So the main thing you need to understand is the source data, which is this one, and the table definition should match. If there are issues with that, you will see inconsistencies with the results. Okay, so if any issue pops up, even though you are getting the results, but the results are not consistent as per your expectations, then the first thing you need to look at is whether the data that is copied and the table that is defined for that data are same or not. The properties on the data and the properties on the table, whether they are same or not. If they are not same, then we will start seeing inconsistent results. I will just showcase. Load data is nothing to do with metadata. No, load data is nothing but loading on. That is not correct statement again. Metadata is only created when you actually run these create table commands, and that will be stored in MySQL database. When you run the query, again this data, you need to have column names. So you have to first you have to check whether syntactically the column names are correct or not. So you have to query the metadata which is defined when you create the table. Okay, and based upon that, it will compile, and then it will create the MapReduce program, and then it will start executing the program. So the metadata will be used only when you actually query the data using multiple ways. One of them is writing typical SQL type of queries, you can, unless the column names you give in select query does not match with the metadata that is generated as part of the create table command, you will start running into issues. Okay. Let us finish this and then we will. I will take the question. Okay. Now we load the data. Loading the data is nothing but copying data from local file system into HDFS. That's it. Whether you have Hive table or not, it doesn't matter. It runs command like Hadoop SS -put to copy this file into the location. So if you think about it, this command. Okay. So if you think about it, this command is nothing but Hadoop SS -put. Okay. And then put requires local file system and HDFS. Our HDFS is nothing but user Hive warehouse cards.db large text. So this command load data local in path is nothing but command like this. It might do some additional things behind the scenes, but you can visualize this command like this. So what does this command do? This command just copy a file from local file system to location in HDFS. Okay, so this load command is nothing but this one. Now, if you want, we can actually run this command. Let's drop the table, large deck. Now the table is dropped, and if you run the DFS command under cards.db, you don't have anything. So first we are creating this table. This command will not do anything in HDFS. It only does, only one thing it will do in HDFS is it will create a directory. Apart from that, it will not do anything in HDFS. But all this information will be stored in Hive Metastore. Metastore is nothing but a MySQL database which that is used to support our Hive database. Okay, I'm running the create table command again. So only thing what it has done when you run the create table command is in HDFS is creating this large deck directory, and it is empty. Okay, so far your only thing that has happened in the HDFS is creating this large underscore deck directory. And all the information which is used as part of the create table command has gone into MySQL Metastore. Okay, now you can describe formatted large deck, and all this information is actually queried from the Metastore. The column names, data types, and all the other properties of the table is queried from the Metastore, not from the HDFS. Only thing that is there in HDFS is this location. Apart from this, there is nothing in HDFS. Now, when you copy the data, either by using load data command or Hadoop SS -put. Earlier I have ran the load data command. Now I am running Hadoop SS. Syntax is wrong, so I have to use DSS -put because Hadoop SS does not work in Hive. If you want to run Hadoop SS commands in Hive, you have to use DSS, which is nothing but alias. Okay, it copied into 2 lines. That's why it created the issue. Now it is copying the file into HDFS. So only thing is this location is defined as the table. That's the only thing that is happening with respect to Hive. When you run this command, there will be nothing that will be happening in the Hive Metastore. Only thing is it is actually copying data from local file system into HDFS. Now after copying this, when you run the query, both Hive Metastore and the HDFS will play a role. What will be the role that will be played by Hive Metastore? Your query has to be compiled. So if it has to be compiled, it has to get the information about your table. and that information is in your Hive metastore. And also it has to process the data to show you the results. And where the data is in HDFS. So when you actually run the queries, first Hive metastore comes into picture for the metadata, then Hive query engine. If you go back to the picture, Hive metastore have the table structure, and this driver is capable of using that information in metastore and generate the MapReduce code. Okay, and also it can compile, it can optimize, it can execute the job. When the job is executed, it is submitted to job tracker or resource manager, and then you know the location from where you have to read the data. So when you run the select queries on top of this data, it will actually go to the DFS and it will get the data and it will process the data. So that's how the Hive query will leverage the metastore and run the queries against the distributed file system by generating the necessary MapReduce code behind the scenes. Okay, so now it is copied, and we have copied using DFS-put. Now run the select command. So this select star, when you use select star from, it does not generate MapReduce code. So don't. That's why it has given the results immediately. But if you want to, let's say, select color.pip color.suite/pip, color, suite, pip from large deck, limit 10. Now it will run MapReduce job. Okay. Why it does not run MapReduce job when you do select star from is it is using commands like tail or head to get the results whatever you want using select star. So it is trying to get the entire data and it is presenting here. So it does not require MapReduce job. But typical queries which actually implement some business logic does not follow select star from. And this might be useful only to validate whether your data is written correctly or not. But as part of your data integration frameworks and all, you should not use select star from. For validation, it is okay. So now when you actually give the column name, it actually ran the MapReduce job. So when it runs the MapReduce job, it gets the data from HDFS to where we copied the data, and it will show you the results. Okay. I will come back to the queries again later. Let me delete this. Okay, now we are talking about insert. So to demonstrate the insert command, I am creating a partition table. The reason why I am creating a partition table is that I just want to tell you that we can actually partition the data in a Hive, and we will see what will happen behind the scenes. I am creating the table. So now, if you see Hadoop, DFS -ls user Hive warehouse cars.db data of cars partition by pip. Okay, it is empty because we haven't copied any data to this. So you can see two tables, one is large deck and the other one is deck of cars partition by pip. And now let us run this insert override command. And let's see what will happen. Okay, I have to give the large deck. Okay, so actually I'm using dynamic partition. So first let me set it to this command, set this parameter and run the query, and then I will show you the results. Now, if you see the difference between load and insert command, load command uses Hadoop FS minus put, similar to the functionality that is implemented using Hadoop FS minus put. It will just copy the data by dividing into blocks into HDFS. Whereas insert, it is actually generating it is actually generating the MapReduce job. And the main difference between the insert in Hive and the traditional insert is that you cannot actually insert individual values. You can only insert the output of a query. So, for example, if you think about traditional queries, you can do like this: insert into table name and C1, C2, and then you can give values A, B, like that in many RDBMS databases. So you can do insert of individual rows as many times as you want, but those kind of inserts are not supported in Hive. In Hive, you can only insert the output of another query into a table. You cannot actually run insert commands like this. So this, if you want to copy data using load data command from one HDFS location into a table, then you just have to remove the locals from here, and you have to give the correct path in HDFS. Then the data from that path will be moved, not copied. It will be moved to the table. So the data will be deleted from the source, and it will be shown in the target location represented by this table. So this command is for local file on local file system to HDFS. If you want to copy data from a HDFS location into another HDFS location represented by Hive table, you can use load data command, but you have to remove the local from the command, and you have to give the correct path in HDFS. Okay. No. There is nothing in table. Table is nothing but a logical structure. Okay. The purpose of insert is also to copy data from data from a table in HDFS into another table in HDFS. Okay. So both will be in HDFS only. That's what. Wait until the query is done. I will show you the results, and I will explain what is going on behind the scenes and where insert will come into picture once the query is executed completely. So it is still running. We are almost there. Yes, that is correct. Load will call minus put and insert will execute a MapReduce. Okay, now it is done. And now let us validate what we have seen immediately after creating the table. So this is the output of the DFS minus ls command after we created the table. There is no results because there is no data in there. Now let us run the command. Let us run the same command again. Okay, and if you see, now there are multiple directories. For each pip there is a directory, so each one is a directory. So when we actually run the create table command, before the major difference between large deck command and the deck of cards partitioned by pip is that we have defined partitioned by clause, and we have given the column name on which data needs to be partitioned. Okay, and now if you see, depending upon the column name which is defined in the partitioned by clause, there are the directories with prefix of that column name. In this case, pip is prefix of all these directories. And then for each equal to is just to tell that this directory is related to the value 10 and all. So all the records that are related to pip 10 will go into this directory. All the results that are related to pip equal to 2 will go to this directory. And now if you go to each and every directory, and if you run the command, ls command, you can see a file over there. So when you actually run the insert command, it actually reads the data from large deck, and it processes in such a way that data is distributed by pip and stored in multiple directories in the cluster. So if you remember, when we what I have explained earlier, when I have executed load command, the source data has to fit the table definition. If the source data does not fit the table definition, and if you still copy the data, you will start seeing the incorrect results. So in such cases where your source data is not in the format you want to store in a Hive table, you can use the insert command. So first you can stage into a Hive table like large deck in this case, and then you can run the insert command to execute the map reduce job, and you can transform the data that can fit to your table definition. So in this case, this deck of cards partitioned by pip is a partition table, which we want to create it as a partition table, and we don't have data partition like that to copy into it directly. So we cannot use load command directly. Either you have to divide the data manually as per your table definition, and then you can run the load command. If that is not the case, you can actually use commands like insert, where you can store into the format you want, and it triggers map reduce job behind the scenes, and it will process the data as per your requirement, and it will store the results as you want in the database. So this is one use case. So actually insert is nothing but to store the outcome of the results in a different table. It could be of any format. So in the cases where you want to change the delimiter, or you want to do some transformation on the data, like if the date is represented in one format and if you want to see it in a different format, you have to apply certain transformation rules, and you want to store in another table. In that case, you have to use either create table as select command, or you have to use insert command, which will run map reduce job behind the scenes, and it will fit into the actual table structure, desired table structure where you want to store this data to. Okay, so that is about insert command, and now we will talk about queries, running the queries. Okay, so already we ran a query in this command, in the insert command as well, and we have seen that it has generated a map reduce job and inserted into the table. Now we are actually running the query, and the query says we want to get the results pip and suite and the count for each group of pip and suite. That is the results which we want to see. And as you have seen, it is nothing but a map reduce job. This is the URL for your map reduce job. You can copy the path, so you can copy the URL and you can paste it in your browser, and you can actually check the progress. Okay, so it is running, and you can actually go to the counters to see how it is progressing and all those things. If whatever you typically do for your MapReduce program, you can do for your Hive queries. Okay, and this query is actually using one job because this query is not very complicated. In some cases, it might even use more than one job. Okay, the results are already done, and you will not see the counters information which you typically see in Hadoop command because that is suppressed by the Hive engine. But you will get information like this: how many mappers are run, how many reducers are run, what is the CPU time it took, what is the I/O it has done to read data from HDFS, and how much output is returned to HDFS. All this kind of information you can get, and this is the actual execution time of your query. And these metrics are important while you are playing, while you are performance tuning your queries. Okay, and now let me run another query where it might take more than one job to complete. No, there is no need for a web UI for Hive. The reason is it uses MapReduce behind the scenes. If it does not use MapReduce, then it will have a web UI for it. And you can actually go to your Cloudera manager, click on Continue, Finish, click on Hive, and you can see here there is no web UI for Hive. If there is a web UI, you will directly see it here in Cloudera manager. Okay, now select star from large deck. Oh, still it is using only one query. In the previous versions, it used to generate one job. In previous versions, it used to create two MapReduce jobs for this query. But that is fine. So it depends upon the complexity of the query. It can actually spawn multiple MapReduce jobs to get the results you want. Let me do this. Let me kill it. Okay, I know how to create a query which will actually generate multiple MapReduce jobs. Okay, here if you do order by pip, suite. Okay, you have to go to the right database. Now you can see that it is actually launching two MapReduce jobs. So now you can go here and you can want to from here, you can click on job, you can go to configuration, and you can see query here by running, by searching for query. You can see the query that is being run by that MapReduce job. And also if you want to see what each job is doing, you can actually look at input.d on this one. Yeah. So if you, this is the parameter. So if you search for this parameter, you can actually estimate what is going on in the job, and also the job name will give the stage. So you should be familiar with these parameters to troubleshoot what is going on in each of the jobs. So this is it is still running the first job. So we are in the first job because we took the IP address of the first job, and you can see that it is actually reading the data from all the partitions. and as part of the second job, it is sorting. So you can go to the second job now, and we will see the results. That input DIR is very important parameter. Input DIR. If you see here, it is actually reading data from a temp storage in Hive. So the first, you can go through each job, and you can actually go to this parameter, and you can determine what is happening as part of that job. So the first job is actually reading the data from HDFS. In the second job, it is actually sorting the output, which is changed because we have written a little bit complex job, which requires more than one map reduce job. Okay, so this configuration is very, very important to troubleshoot many issues, and make sure that you keep this in mind whenever you are troubleshooting issues in Hadoop. Okay, so now we ran the job, and you can validate the results. They are sorted by tip and suite. They are actually sorted by alphanumeric. That's why you got 10 first, and then 2, 3, 4, 5, etc. Okay. So that is about Hive queries, and let me see if I miss anything. Okay, now you can actually, one more thing is actually when we run Hadoop jar command earlier, if you remember, let me run one more time. So tables. So select count 1 from large deck. So if you see, the number of mappers is only 9. Okay, but when we run Hadoop jar command in the morning, when we started the session, I think it's not here. Yeah, here in this only. So if you look at this job, it has used 17 splits. Okay, so it has used 17 mappers because it has used 17 splits. Let me show you here. If you go to the counters, and if you look at job counters, we have launching map task set 17. Okay, whereas here, when I run the query on large deck, it is using only 9 mappers. Okay, the number of mappers is 1 because actually you can see it here. In order to set a constant number, I think let us probably it is using 1 because of the nature of the query, or it could be set upon the Hive RC file. Don't worry too much about number of reducers, but if you look at the number of mappers, it is 9 here. Whereas when we run the map reduce job in the morning to get the same results, it has used 17 mappers. The reason is Hive by default will try to set the split size to the double of the block size. In our case, block size is 128 MB. So if you run this command, Hive -e set, and then pipe it to pipe and grep for split. And if you hit enter, so this is the parameter which will determine the split size. Okay, and if you go back to our web UI, and if you go to So this is the first job which we ran in the morning, and if you search for it, okay, the first job history, why it is not true? That is fine. The switch size is only 128 MB because when you run a typical MapReduce job, the split size will be defaulted to the block size. Whereas in Hive, it will override that value in hivesize.xml file. So if you do sudo su, or actually you can look it from this, sudo su root and val run Cloudera SCM agent and process lsltr cd 205. What? Okay, I think it is as part of the Hive engine. It will override. Somewhere it will override, and it reflects 256 MB. So as it is using 256 MB, it is actually creating 9 mappers to process the job. If you increase the parameter, okay, now let us run Hive again. Use cards and set. It is 256 MB. If you change it to 1 GB, and if you try to run the query, now it will only use 3 or 4, I think 3 mappers to process the data. So that is the relevance for set. You can override the parameters such as reducers and split size to change the usage of resources and tune the performance of the query. Okay, earlier when we run the query with 9 mappers, it took 51 seconds to get our results. Now let us see how long it will take. .999 seconds. Now it took 51.979 seconds. So even though it is using lesser mappers, still the performance is equal. So increasing the split size to 1 GB might be better than running with 256 MB. So you can actually use this information to understand whether your query is actually running faster or slower, and based upon that you can tune your queries at runtime. Okay, so that is it about Hive. Let me see if I miss anything as part of the demo. Yeah, so troubleshooting MapReduce jobs, I have already explained .hive.rc. Yeah, one more thing is we have to talk about the user-defined function. So there is nothing much here for user-defined function. What you have to do is you have to get a jar file from the developer, and then you have to get the class name using which you want to create the function. And once the function is created, you can use that function to run your queries. So only these 2 steps need to be taken care by the administrator. They have to use the add jar command to add the jar file which is provided by the developer, and also administrators have to execute this command. And to make it persistent for all the sessions triggered by the user, you have to update the .hive.rc file. Okay, so sorry. Here, what you have to do is you have to go to .hive.rc and you have to update this file. And once you update, you can use that function. So it is very straightforward. And when you create the function, you also need to get the instructions from the developer about how to validate that, and you should validate that before saying that the deployment is successful or not. I'm not going into steps and demonstrating that, because that is not that important for administrators. Only thing they need to understand is the steps that are involved. Okay. Now, and what else? Yeah, that's it. Only thing I need to show is how you should troubleshoot. As I mentioned to you earlier, to troubleshoot the issue, there are two sources. One is Hive log file, as I mentioned to you earlier, and then other one is to monitor your MapReduce jobs. So the location for Hive log files is /temp/SD user. Whatever OS user you are trying to use to run your queries, you have to go to that directory under /temp, and then you can actually look at hive.logs, and it will give you all the details about your query. So if there's any issues with your query, if it failed in between, that information also will be logged here. So before getting into the logs of your MapReduce job in the web interface, first you have to check the hive.log file, and if there is an issue, you have to then troubleshoot the issue to get the more information as part of the MapReduce logs in the here. Okay, so that is it about Hive. I am stopping the recording, and if you have any questions, let me know.